Hello, my name is Robin Mitchell, and today Electropages is here at Embedded World in Nuremberg, and I'm joined by...
I'm Shahzeb. I work at technical marketing at ATV, automotive microcontrollers for Infineon. And we've just announced Rust support for our Preview and RX microcontrollers.
So as I understand it, you're now bringing Rust, the programming language, to your microcontroller range. But from an engineer's perspective, what actually is Rust, and why is it advantageous for engineers?
So Rust is a modern systems programming language which emphasizes memory safety, performance, and concurrency. So it allows developers to write a fast and efficient code without sacrificing reliability or safety. With the embedded Rust, so the support for Rust on embedded systems is currently very limited, especially when you talk about deep embedded systems. So with embedded Rust, you have the same capabilities that Rust provides for normal non-embedded programming. Basically, you're writing performant code on embedded systems, which emphasizes or leverages Rust's safety and reliability features, including low-level hardware access.
And so it's more focused on creating systems that are safe and deterministic. So,
yes.
So let's say you're doing like motor controls or something. It's about making sure that the code doesn't.
So where Rust differentiates it from other programming languages is that it provides a lot of compile time guarantees on the behavior of the code. For example, if you were developing memory safe software in the traditional way, for example with C, what you would do is you would write some code based on some system design that you've done. There's a lot of developer experience that factors into this as well, the coding guidelines. You write your code, you do some static analysis on that code reviews, and then testing on the actual system. So the later in the development life cycle that you find bugs and fix them, the costlier it is to fix bugs. And of course, if a bug actually creeps into a production system, they can also have catastrophic, let's say, outcomes. So Rust provides guarantees that a lot of these memory issues that you have with traditional approaches to writing software are not there in the software that is actually running on the system. And this is done at the compile time. So Rust has this concept of ownership and borrow checking. And what it does essentially is that if I declare a variable, I am the owner of that variable. And as long as I don't pass that variable in very layman terms to another function, I can use it. But as soon as I pass it to another function, for example, the ownership transfers, and I cannot use it afterwards until that specific function does not return that back to the original function. And then there's also this concept of lifetimes. So you cannot access a variable in Rust beyond its lifetime.
Right.
This is especially important for when you talk about threads. So if a variable is accessed in a thread which can essentially run in its own runtime concurrently, and if there is a risk that that specific variable won't have the lifetime required for that, you will get a compile time error for this as well.
And so with these lifetimes and borrowing, it basically makes sure that functions execute a certain way and it doesn't hold some other function that might be.
So it reduces the undefined behavior that you would the risk of undefined behavior in your code.
Right. Okay. So what example have we got showing around here at the moment?
So the example itself is very rudimentary. What we're essentially doing is we're sending some CAN messages from the PC to our RX board.
Here.
Yeah, this one. And
so this is your CAN bus here.
Yeah, this is the CAN bus interface. Yeah. From there, we are transferring the information that we have from CAN to UART. Over UART to our Preview board, and it's basically blinking some LEDs based on the information from the CAN device. So what we're showing over here is basically the ecosystem that we're trying to develop for Rust. For our Preview devices, because they are based on ARM, we've used the standard ARM toolchain for Rust. For RX, because it's a custom architecture, a custom compiler for RX for Rust was developed in collaboration with our tool partner Hitech.
Right.
But for both of these cases, we have peripheral access crates, which will be made publicly available. There will be code examples, which will also be made available as open source. And we also want to engage the open source community in developing Rust further for Infineon microcontrollers. And Infineon is basically the first major semiconductor manufacturer which has announced official support for Rust, which means that we will release the peripheral access crates, or in layman terms, the hardware wrappers used to access the hardware in Rust, and we will also maintain them. And we also plan to enhance this support further by developing hardware abstraction layers and drivers.
Brilliant. Just before we dive into sort of the SDKs that you provide, can you give me a bit of history about Rust? Because it clearly looks a bit like C, and I've always struggled to understand what it really is compared to things like C and C++.
Rust started off as a personal project from an employee at Mozilla Research. This was way back in 2006.
Yeah, I remember this.
Yeah. So what they wanted to do was to create a language which does not have the same security pitfalls that C or C++ have. And essentially, the idea was to develop a browser engine in Rust. I think the name that they used was Servo. And the idea was to develop a secure browser engine which does not have the same security vulnerabilities as other systems.
That makes sense for browsers, because when you get things like buffer overflows, you can get access to private data like keys and stuff. So the idea of Rust is to create memory safe functions. Yeah. So you can't accidentally or on purpose overflow the buffer or access some other function's memory.
Exactly. And also like buffer overflows or hanging pointers or null pointers. And the thing is that there was this research done by Microsoft in 2019, and this same results were echoed by the Chromium project in 2020, that 70% of the security vulnerabilities in the system were due to memory issues.
Do you know what? That actually makes complete sense. Every single time I've seen another patch for like Heartbleed, for example, it's always memory pointers and buffer overflows.
Yes.
It's never. It really is. It always is memory issue. So it makes sense that you want to bring Rust onto a microcontroller.
Yeah. And so basically the first public release for Rust was 2010, with the first stable release being in 2015. Since then, there was this Rust Foundation formed in 2020, which the founding members include Google, AWS, Mozilla, and there's Huawei as well. So these are all the founding members, and they are the ones who are basically managing Rust right now. And there are then different levels of members of the Rust Foundation, includes silver level, platinum and gold level, different levels. So there's already a lot of Rust adoption in, let's say, in the server space, backend services being written in Rust. I think since in the last 7 years, Rust has been the top programming language on Stack Overflow.
It really?
Yeah, so 7 years consecutively.
Wow.
Yeah.
Quite surprised. That's really gone up, hasn't it?
Yes. And consider the fact that Rust has been around for only 8 years as a stable release.
That's pretty fast for a language.
Yes. And there's definitely a lot of interest in developing code in Rust also for embedded systems. But if you talk about high-end embedded systems where you have embedded Linux or QNX running, writing Rust code over there on those targets is actually the same. I mean, you have the same developer experience like you would have on developing on a host PC. But for deep embedded systems, there is currently a lack of an ecosystem for Rust development, and that is where we come in. We're trying to develop, we've taken the first step in trying to develop an ecosystem for Rust on embedded systems.
And does that make Infineon the first to bring Rust to embedded systems?
Yes.
Oh wow!
Yeah.
Really.
So I mean, at the moment there is Rust support available for other microcontrollers, but it's mostly community-driven. But if you talk about,
you're trying to standardize it from an industry point of view.
Yes.
So obviously the community can do these things, but what you're bringing is organization, structure, and the kind of the industry know-how to make it standardized, to make it easier for engineers all over the world.
And this also involves collaborating with specialized companies who know how to develop safety critical software, who know how to develop software which is built using qualified tools. So one of the key components of writing safety, functional safety software is that the tool chain needs to be safety certified as well. And our partners which are developing the compiler, they are actually planning to safety certify their Rust compiler as well.
Which is what makes it very different to the community project. So,
Exactly.
So the community project is use at your own risk.
Yes.
But Infineon's going to be like, no, ours is actually safety certified. So
Yes.
you can be sure that your code is not going to fail and cause you issues.
Yeah, and of course there are efforts going on to also come up with a standard on how to develop software in Rust for safety critical or more specifically for automotive applications.
Brilliant.
And one interesting fact here is that recently NSA made this press release where they said that developers should look to move away from unsafe languages, and they suggested that they should be looking for memory safe languages, and Rust was one of the languages that they suggested should be used for systems where security and safety are critical.
Like medical, possibly industrial, and definitely automotive.
Or definitely automotive,
Definitely,
yes.
yeah. Especially with self-driving systems where you don't want them to fail, and the whole thing cascade fails, and then yes, that's brilliant, absolutely brilliant. So just before we head off to a different demonstration, and we're going to get a different expert to come in, if there's an engineer who's watching this video and wants to get involved with Rust and Infineon products, what would you recommend that they do?
So for Rust, we have a dedicated landing page. If you go to infineon.com/Rust, you will find all the information and all of the subsequent developments we do regarding peripheral access traits, code examples. All of them will be eventually listed over there. So that is the best place to find more information about Rust, or reach out to us using the Infineon developer community. We're always there. There are actual FAs and engineers, Infineon engineers who look at the posts at Infineon developer community.
Fantastic. Thank you ever so much for having me today.
Yeah, pleasure talking to
meeting
you.
Pleasure meeting you, Fred. So now we've come down to a different demonstration done by Infineon, and I'm joined by Chi, who's going to show us a bit about their new NFC solutions.
Yes. So we are showing here energy harvesting with NFC. So you combine energy harvesting with communication. So you can do a lot of interesting things. So one thing I would like to show you is a smart lock without battery. So in this case, the mobile phone builds communication with lock, and at the same time, our IC harvests energy from the NFC field.
There's no battery in that, is there?
This is no battery inside. If you don't believe, you can take a look here. So this is open. You can see there's no battery.
No secrets.
No secret.
No magic. No.
So everything is a single chip solution. You just need an antenna, and you need a capacitor to store energy, and then that's it. That's total solution, a single chip.
And so by charging over a period of time, you can release that energy very quickly to power like a larger inductor or something.
Yes, because we have here also integrate H-bridge to control the motor.
Yeah.
And our IC will monitor what.
So specifically designed to drive a motor?
Yes, we have everything in one IC. So it's really specifically designed for the smart lock application. Yeah.
Oh, right. Okay. I
but-
didn't realize that. That's quite interesting, because normally I would expect that you'd have like a power out,
Yes.
and then it's up to the engineer to decide how these are powered. But you've actually integrated into a single solution.
Yeah. So reason for that is we harvest energy. So you get 20 milliwatt, 30 milliwatt power. It's relatively small amount of energy. You want to use it very efficiently. So if you need a separate component to control the power, then you lost in between. So we integrate everything here, and also the IC manage the power. It's more efficient.
So if we just look at this design here, that board there with the
Yes.
with the NFC on the back,
Yes.
those are the only components you require,
Yes.
and then that will basically make the entire system work. So could you show us? Does this demonstration work? Could you show
Yes. So this is a 3D print sim, and you see this latch come out and goes
yes,
back.
I see.
And I hope you can see that. It's
We
basically
can
the
always
same.
do a close up in a second.
Okay, so here you build connection, and then you see
yes,
it comes
look at
out.
that.
Right? It's finished.
That's incredible.
And you unlock, just move it back.
Right. So now I've got a question for you.
Yeah.
You can lock and unlock.
Yes.
Does that mean that you're not just transferring power, but you're also transferring data?
Yes, of course. All communication between the mobile phone and the lock is encrypted.
Yeah.
And before it starts to do anything, it does a first authentication, that there will be a key exchange, and to test whether you have the right key to open the lock. Yeah.
And so you're not just providing power, you can also tell it which way for the lock to move. And so by doing that,
Yes.
you can actually integrate a lot more features from a single chip solution.
Yes, and also with mobile phone, you have a lot of function. For example, you can share the lock access with other people. So for example, here you see how many lock I have access. And if you select here, I want to share with other people, you can share with other people.
And so there's no more need for a physical key because you can say to your friend, oh, my bike's over there, can you unlock it for me?
No.
Send them the digital key
Yeah.
and they can unlock it themselves.
Yes, that's the reason why we make this product, just to skip the
That's
physical
absolutely
key.
brilliant.
But not just about the lock.
Not just
We
locks.
also have a very interesting thing here. With the same energy, you can also do sensing. You can think about you have a sensor node without battery.
Yeah.
You can put somewhere in the building, in the machine, and then you can use mobile phone to read and sense data. And with this one idea, one of our partners, they built one product demo, which is a blood pressure measurement.
Right.
So we have our IC here and integrated with Infineon pressure sensor.
Right.
So everything what you need is so simple, just like this. One antenna, IC, pressure sensor. And then you do the normal measurements, put your mobile phone here, your mobile phone powers the sensor, and so you still need some pumps to mix pressure.
And as you pump it, the pressure increases, which it detects.
It will be measured here, and then the result will show in your mobile phone. And the nice things, you have all data in your mobile phone, you send it to your doctor somewhere, cloud, and then this enable also cloud-based medical service.
Would that be a different chip to this one here?
This is a new chip, and
Yeah.
we added the sensing unit. So basically, we have
it's
two
the
IC.
same chip.
Basically, we have two IC. So one IC is for lock without sensing, and this IC is a new one with integrate the sensing unit.
So it can still be a lock, but it can also have this analog
You're right.
reading. Oh,
Yeah.
brilliant, brilliant. So if that's for the engineers who are watching this video,
Yes.
if they want to get into these products, what would you recommend?
So every information is online. We also have the software SDK available online. We have also the development board. My recommendation is find a distributor from Infineon or go to Malta. You can buy our development kit.
Oh, that's quite useful, yes.
So as soon as you get the development kit, you get access to all the documentation online. You can download SDK for mobile app, for firmware, that you can start your development.
Brilliant.
Yep.
Well, thank you ever so much for taking the time to show us these products. Fantastic.
Thank you.
Thank you.